All right, here we go. Just a quick review. I'm going to go through page 141, 1 through 3. A few questions came up that hopefully we can help answer, get a little bit better understanding on the material. So again, number 1, you've got a box, flat surface. So the mass of the box is still, actually the mass is 35 kilograms. Coefficient of friction is 0.27. The force applied is 185 newtons. And the angle that this is being applied at is 25 degrees. Okay, so this is what they were given, and I believe, and they want you to find acceleration. So just like we always do, we start at the bottom, find f of g. Force due to gravity, 35 times 9.81. Then we can go right in and go, okay, force applied. Another pin died. Hope someone's keeping track of how many pens we've killed today, or this year. So the force applied at 185 newtons, we got to do f of g, or f applied y here, and force applied in the x here. So again, you split the 185, the opposite angle, so in this case sine of 25. And this one, 185 adjacent leg to the angle is cosine of 25. Going around the horn, might as well, we've got to find f of n. Up equals down. The two things that are up are f of n and force applied. Force applied y. Those are the two things that are going up. Equals what is down. And last but certainly not least, we've got a friction slowing us down. F of k. And again, f of k should be coefficient of friction times f of n. Let's do some calculations. 35 times 9.81. That means this is 343.35 newtons. So then we have 185 cosine of 25. This is 167.7. And then 185 sine of 25. That's 78.2. We bring those down here, force applied in the y, 78.2. Our gravity, we said it was 343.35. 343 minus gives us an f of n of 265. Wow, if I could write, that'd be awesome. 0.2. So that's my f of n. We'll take a look. We got f of n, so 265.2. We had a coefficient of friction of 0.27. Our f of k is equal to 71.6. A lot of information. We just went through a lot of things just to get all the data on this chart. The last but certainly not least thing, every single time we'll do the sum of the forces in the x direction. The x direction. The x direction. speed up minus your slow down. In this case, we're not on an angle. We're not on a surface or an incline, so the only thing speeding me up is the force applied in the x, minus force due to friction. So in this case, force applied in the x, 167.7 minus 71.6. My sum of the forces in the x direction equals 96.1. Again, slightly rounded. Looks like my video has stopped. That's awesome. Give me 1 second. Let's figure this out, because apparently it's going to be a... There we go. 96.1 is my sum of the forces. Well, we know this is equal to mass times acceleration in the x. And we said our mass was 35. Acceleration in the x should be 2.75. Video number 1. Hopefully this helps. Double check your answers versus what's on the book.